Diamond Plastics Corporation was founded in 1982. Since that time, our singular focus has been gasketed PVC pipe for water, sewer, and irrigation applications. In the last 10 years alone, Diamond Plastics has shipped approximately 30 million feet of PVC pipe every year. The reason for this explosion in growth is due to the superior performance record of PVC pipe, which has been used in the United States for over 50 years. At Diamond Plastics, our people take pride in manufacturing and supplying our clients with the highest quality pipe product available. We know that protecting your water resources is becoming increasingly more important, and that long-lasting, reliable pipe can help achieve that goal. Because of our decades of experience, Diamond Plastics has become one of the world's leading manufacturers in high-quality PVC pipe, boasting the world's largest diameter gasketed pipe at 60 inches. Diamond Plastics has also grown by supplying PVC pipe for industrial and municipal applications. Starting out with 2 facilities, Diamond Plastics now has 7 geographically strategic plant locations across the United States. We all use PVC pipes every day, even if we never see them. They carry water to and waste from our homes, businesses, and schools, improving the health and convenience of our everyday lives. Polyvinyl chloride, commonly known as PVC, is a durable, rigid plastic originally invented over 100 years ago. The basic PVC resin can be blended with various additives to create many strong but flexible products like garden hoses, or, as Diamond Plastic blends it, into superior corrosion-free, non-toxic pipes. The raw materials used to make PVC come to the plant facility by rail cars and trucks. The majority of the incoming raw materials are stored in silos or rail cars just outside the plant building. Creating PVC starts with a specialized batch of ingredients carefully blended together for each specific application. The individual recipe for the PVC depends upon the end application. It generally consists of the primary ingredient of resin and 5 to 8 different raw materials. Water and sewer pipes, for example, have similar but very different recipes. The exact ingredients and quantities vary as to which type of pipe is being produced and are created to strict industry standards. These governing standards are also used later in testing the finished product. The raw materials enter into the plant blending room and are stored in separate micro hoppers. The higher usage materials, such as resin and calcium carbonate, are stored in silos and vacuum conveyed back into the mixer system through pipes coming from the storage silo. Depending on the blended mix desired, the materials are combined in both a hot and cool mixer. Paddles and blades inside the mixer blend the raw materials together. When it's time to make pipe, the mixed compounds are then moved from the holding silos to hoppers stationed above the extrusion line. The powder compound is gravity-fed down from the hopper into the extruder. Heat stabilizers and lubricants that are blended into each compound help the PVC compound move through the equipment. The extruder consists of a barrel and precision set of screws, as well as a motorized drive system. The compound enters the extruder and is augered through the barrel by the screws, which apply compression and heat to the PVC material. The proper application of pressure and temperature turns the compound into a hot, pliable material suitable to push through an extrusion die into the desired size of PVC pipe. The die consists of several components held at precise temperatures above 300 degrees Fahrenheit and culminates in a sizing sleeve, which determines the outside diameter of the pipe. As the PVC exits the sleeve, the thickness of the pipe wall is determined by the speed the pipe is pulled from it. This controls both the inner and outer diameter of the pipe and wall thickness to match specific industry standards. A solid wall pipe from Diamond Plastics can range from 1.5 to 60 inches in diameter, which is the largest solid wall PVC pipe made in the world. Air pressure helps to expand and hold the shape of the pipe. The hot PVC is then moved through a series of cooling tanks that sprays chilled water to cool the material and retain the dimensions of the pipe. Each spray tank uses recycled water that is processed within the plant facility, reducing the environmental impact. At the end of the cooling tanks, a puller controls the speed that the pipe is traveling. A precise speed is required to ensure that the walls of the pipe have a consistent specified thickness. Prior to the pipe moving into the puller, an inkjet printer imprints specific manufacturing information on the cooled product, allowing every piece of pipe made to be tracked. In this particular case, 60-inch cast iron OD pipe with a dimension ratio, or DR, of 51 is being produced. Currently, Diamond Plastics is the only manufacturer in the world capable of producing this product. After leaving the puller and having the print line applied, the pipe enters the saw. A large clamp will lock down around the pipe and begin moving with it as a carbide tip saw blade begins cutting the pipe to typical laying lengths of 14, 20, or 22 for this line, and 40 or 44 feet for other smaller diameters. As the saw blade rotates around the pipe, a chamfered blade will cut an angle for a beveled connective edge on the spigot end of the pipe. When the pipe leaves the cutting process, workers will carefully measure the wall thickness of the pipe to ensure superior quality and consistency. These measurements are wirelessly transmitted to the computer-stored production records. In order for the pipes to fit together, a gasketed bell is formed on the non-beveled end of the pipe. As you can see, many levers are used to move the pipes into position for the belling process. In order to make the bell, the end of the pipe is moved into a heater to make the PVC pliable again. The pipe is rotated to maintain a consistent temperature around the circumference of the pipe being belled. Diamond Plastics uses what the industry considers the best joining method by providing a rebar gasketing system in the bell of their pipes. To form the bell, a steel form called a mandrel is used to create the proper shape. A rubber gasket is loaded onto the mandrel and moved into position. When the pipe reaches desired pliability, it is pushed onto the mandrel and over the gasket to create the proper shape. The bell is formed around the gasket. This rebar process produces a gasketed joint, which provides superior resistance to the difficulties the construction process may cause. It will now be moved to quality assurance and packaging, unless it is a water pressure product, which requires hydro testing. A computer-controlled cart moves the water pipe down to the online hydro testing area. Once in position, a cap and plug are applied to the spigot and bell ends of the pipe. The pipe is filled with water and then pressurized to the required test pressure, which confirms that both ends of the pipe are watertight and can withstand the applicable standard pressure requirements. Quality assurance testing is an important part of the manufacturing process. Besides the online hydro testing, Diamond Plastics conducts a series of other tests to confirm that their PVC products measure up to exacting industry standards. An impact strength test ensures that the wall of the pipe can withstand an impact. And a 20 or 30-pound weight with an A or B tup is raised to a specific product-related height before being dropped onto the pipe wall. Any crack or breaking in the pipe would indicate a failure. Stiffness testing determines the vertical load pressure that the pipe can withstand to meet industry standards. This is of particular importance for sewer pipe. Another sample of pipe is loaded into the test fixture, and a hydraulic press pushes down at a prescribed rate. The readout indicates the load applied to the test sample, which is used in conjunction with the amount of deflection to determine the sewer pipe stiffness. A flattening test is performed in which a sample of pipe is hydraulically flattened to 40% of its original diameter, or deflected by 60%. PVC is capable of flattening until the opposite sides of the wall touch. Once removed, it is checked for any cracks or breaks in the material. A fusion test is performed by placing a properly prepared sample into an acetone immersion bath for 20 minutes. When removed, the technician looks for flaking or lifting of the PVC, which would signal a failure and suggest an improper material fusion during the extrusion process. To meet standard requirements, pipe is routinely burst pressure tested. A section of pipe is capped and lowered into an in-ground test bunker, and a heavy metal cover is moved into place. The pipe is filled with water and the pressure increases at a specified rate. For AWWA DR18 products, that pressure is 755 pounds per square inch. Pipes are required to reach these levels without failing. Internal pressures in excess of 1,000 pounds per square inch are routinely required to cause failure. With manufacturing and testing completed, the pipes are bound together in bundles depending upon their size for ease of storage and transport. Diamond Plastic employees load bundles of pipe on the flatbed. Then the drivers tighten the straps, which securely hold the pipe load. Once all of the pipes are loaded and tied down, the truck will move to the exit area of the facility. Numbers are placed on each trailer and recorded along with each load's corresponding tracking number and destination information. This system allows for reliable tracking and service to our clients. The tractor trailers haul the pipe all over the continental United States, Canada, and Mexico. Depending upon the construction project, it may require one or dozens of truckloads to transport to the construction site. Once installed, they will begin their reliable service in our everyday lives. They may be unseen, but PVC pipe, manufactured by Diamond Plastics Corporation, plays a critical part in our water, agricultural, and waste management today and into the future for all of us. Diamond Plastics Corporation, with facilities around the country, the investment in technology, people, and a quality product that's made to last.